All right, gang, first video, first instructional video, lesson number one, video number two. Well, actually, the first video would be the first instructional video, but this is the first instructional video where we dive into the use of my stat lab. Now, let me explain something to you. This STAT1150, you'll see me click it a lot. This is where I'm building the course. So once I build the course, then we'll copy it and we'll title it, STAT1150. Spring 2023, whatever term that you're taking the class. But this is just where I'm building the class, so don't want any confusion there. And you will go to assignments and click this, lesson number one, demo for video two. I'm going to go through my option and let's see, and I'm going to just preview this. All right, so the first question says, in a survey conducted by Wedding Planning Website 1183, and again, you may not have this very number, but by the time we work this, you should be able to take what I'm teaching you and apply it to the problem that you're given. So it says the importance of getting down on a bended knee. Okay, I did not get down on a bended knee, by the way. I guess that makes me a bad person. But 58% said that the bended knee was essential. Complete parts A through. All right, so what is the exact value of 58%? That is 58% of 1183. Well, I'm going to grab my calculator and just type in, of course, 0.58 times 1183. And I get 686.14. So I am going to enter that, check my answer, and good stuff. Now, could the result be the actual number of survey who was on a bended knee? Well, obviously it couldn't, because we can't have 0.14 of a person. So I know that either A or C is the correct answer. So let's see which one it's going to be. So no, the result from part A could not be the actual number of survey respondents who said, because that's a rare outcome. Well, it doesn't have to do with it being rare, statistically speaking. It has to do with we can't have 0.14 of a person. No, the result could not be the actual, because this count must be a whole number. So clearly, C would be the correct response. What is the actual number of survey respondents saying that bended knee is essential? Well, we're going to round this appropriately. So if this was 686.5 or higher, I would round to 687. It's not, so I'll round to 686. And among the 1183, 90, excuse me, 96 said that a bended knee is corny and outdated. What percentage? So what I would need to do there is to take take 96 and of course divide it by the whole, 1183. And I get, what does it tell us? Rounded to the nearest whole number as needed. So I guess that's just 8%, right? Because when I put that in my calculator, it's 0.0811496, so on. So move the decimal place 2 places to the right, and 8.1 rounds to 8. All right, the next question we get into is we get into F-scale intensities of tornadoes. So this is the first question that we have where we can access it using StatCrunch. So I can click that icon there, or this picture, and I can see that I have F-scale intensities that are primarily zeros, ones, twos, threes, and fours. Now, what I can do here is I can open this in StatCrunch. It's going to check my login credentials, so hopefully I pass the test. Hopefully Shawnee has paid my StatCrunch login. So I have this listed as variable. If I wanted to change that, I could. F1 stats, yeah, whatever. I can call it whatever I want. So to get a frequency distribution, I always have a hard time finding this. I go to table and then I want to go to frequency. So I have select column, that's the name of the variable. The next thing I want is the frequency. And I'm not going to do any of this in this problem because my bins are just the value of the intensity of the tornado. So I'll hit compute, and you can see that I get my frequency distribution. So I'm going to have 0, 1, 2, 3, 4, and then I'm going to have these values. So let's go back over. Sometimes it helps to get a split screen on this. Let me get some coffee here. It's kind of early this morning. So I want my 0, 1, 2, 3, 4. Let's shut this down. Makes it kind of clumsy to enter the answers. And then I'll have 23, 13, 2, 1, 1. I'm going to check that. Just go back over and make sure that I didn't make a typo. You get 2 attempts at each problem. Well, you get infinitely number of attempts at the problem, but you get 2 attempts at these numbers. If you don't get it correct in 2 attempts, then it'll issue the same problem, just different numbers. So I always feel, kind of goofy when you make a typo, and I make a lot of them, so I'm an expert at it. Do the intensities appear to have a normal distribution? Okay. For reasons I won't go into, this is a place where the author and I have major issues. A normal distribution is more than just a symmetric distribution. That's what he's implying at here. But we'll play his game. And again, one for which I completely disagree, but and one that I'll explain in much more detail in lesson, I think number 3, when we get into normal distributions. But a normal distribution, again, according to him, would have the center, in this case 2, as the highest number, and then 1 and 3, the 2 that are adjacent to the left and right, would be less than, but approximately equal. And these, the 0 and 4, would be even less than the frequencies of the 1 and the 3, and about the same. So imagine a 2 being like a 10, and then 1 being an 8, and 3 being an 8, and then 4 being a 4, and 0 being a 4. Then this would be a normal distribution. So I know the answer is no, because we have what's called a symmetric distribution, or I'm sorry, a skewed distribution here. And again, I'm going to teach you a lot more about that later, but right now we do not have approximately symmetric. Or low and proceed to 1 or 2, then decrease. That's not the case. Start at a maximum and become low when the distribution is not symmetric. So clearly C explains our situation the best. All right, now we get into a different situation. We're talking about service wait times, drive-through service times for Burger King. All right, so here we're going to have quantitative measurements that vary from the F1 statistic from the tornadoes. We can't create bars for each of these numbers. Well, I guess we could, but it would look like a really goofy distribution. So what we're going to do is we're going to create these bins, and we're going to create the bins based on the information that's provided in the problem. And we'll open it up in StatCrunch and perform the calculations. So lunch times were measured. That just tells you the population under study. When are the measurements taken? But this is the important part right here. Begin with a lower class limit of 40 and use a class limit of 70 and use a class width of 40. Class width of 40 doesn't mean that I go from 70 to 110. It means I go increase from the left endpoints by 40. Now, this service time, if it goes from 70 to 110, then this would have to go up to 109. This would have to go up to 149 for pretty obvious reasons. And then this one, if I increased the 230 by 40, I'd be up to 270. One less than 270, which would be the bound, upper bound defining that particular band, the 230 to 269. So the next thing I want to do is I want to open this to StatCrunch. I could actually go through and just count. How many do we have between 70 and 109? There's one, and there's one. I just don't like doing that. That would drive me absolutely insane. So what I'll do here is open the data set in StatCrunch and give it a new name, wait times. Don't have to do that, but I do. Go to table, go to frequency. I want wait times. Now, I want my frequencies as well. But I need to come down and create my bin numerical values. So I want to start with, just as the problem said, 70. And then I want the width to be equal to 40. All right, compute. And I can see that the values are 10, 20, 6, 6, and 3. Need some music or something in the back. The quietness is crazy. All right, so we checked the answer and we got it correct. Okay, good deal. Next question, refer to the table of service times of dinners at fast food restaurants. How many individuals were included in the summary? Well, we can just add these up. I see 30, 46, and 8 is 54. If you're not good at that, just grab your calculator. If you would prefer to do this with StatCrunch, sometimes it's better to do it, be very careful, especially when your grade's at stake. It's very easy to do. Just go to Stat, go to Summary Stat, go to Column, and I want to add up the frequency column, these numbers right here. So I just come down here to Sum and Compute, and you'll see I get 54. Now, I think this is a pretty good time to pump the brakes and emphasize to you just how important keeping a notebook really is. Because I'm throwing a lot of stuff at you, and this is really low-level stuff that we're doing today in this instructional video. We're going to get pretty complicated with some things. So you, at this point, probably don't understand StatCrunch as well as me. That's okay. I'm not going to ask you to do anything in StatCrunch that I don't demonstrate in an instructional video. So the fact that you organize yourself, you organize your thoughts, you organize what I teach you in the instructional videos is extremely important, in my opinion, because I'm going to ask you to do this stuff again for a grade. Well, this is kind of a grade too, but these are low points. I'm going to ask you to do this stuff again on an assignment. I'm going to ask you to do this again on an examination. So is it possible to identify the exact values of the original service times? Well, it's not, because, for example, the first bin, the times run from 60 to 119. I know there's 8 in there, but I don't know what they are. So I know I'm going to check a no. So I would say look at the frequency distribution tells nothing about the data beyond the data fall below the lowest class and above the highest class limit. I don't think that's great. No, the data values in each class could take on any value between the class limits inclusively. So clearly D is the response. All right, now we're going to look at relative frequency, which would be the percentage. So a couple of ways of approaching this. I would probably perform it the easy way. So I would find my sample size, which would be 4 plus 14 plus 13 plus 4 plus 3. So we have what, 18 plus 17, 35, 38. So I would just take 4 divided by 38. And I get 0.105263. And it wants us to round to 2 decimal places. So there I would put 10.53. Notice the way that I rounded there, right? The 0.52. So I have 0.1052, but because that fifth digit is 5 or bigger, I would round appropriately. Next thing I would do is 14 divided by 38. So 36.84. And don't put the percentage in there or you'll get it wrong. You're communicating with the machine here, so keep that in mind. So I get 34.21. 4 divided by 5. And I'm going to show you how to do this with, so 10.53. I'm going to show you how to do this with, see, fat fingers got in the way, so make sure you check what you're doing. And then 3 divided by 38 is 7.89%. Now, I'm going to check the answer. It's going to be correct, but let's see how we could have done this with StatCrunch. So click the icon, open in StatCrunch. Again, we can rename that if we want. It's not important. But we go to table, frequency. I want variable 1, and I want the relative frequency. All right, that should do it. You know what? That's not going to do it. We have to take a different approach here. Let me tell you what we have to do. We have to build an expression. So to do that, I need to come to compute and go expression. So what I need is my variable 1. So I'm going to go to build, and I'm going to go variable 1, which is the variable name, right? var1. And I need to divide that by 38 and then multiply it by 100 to get it into a percentage. Hit compute. And you see I get 10.53 and 36.84, just exactly like we did by hand. All right, let's move on. So we're going to get to a little bit more now. We're going to get into what are these values on the left, the bins, what's the left endpoint called? What's the right endpoint called? We're going to get into more information really about the definition of a frequency distribution that uses bins with a class width. So identify the lower class limits. Those are just the left bounds of each bin. So it's just going to be 10, 12. I wish really they wouldn't require us to do so much typing, but oh well. At least it's easy and we're getting it correct. All right, identify the upper class limits. That's just going to be the 11. and the 13, 15. All right. Now identify the width. The width is just going to be the distance. So this one's really easy because the width just goes from 10 to 11, so the width is just 1. But what if the width was, say this went from a 10 to a 15? Well, the width is just the highest minus the lowest. So, okay, wow. I'm actually kind of glad this happened because I got sloppy. So that's incorrect. Why is it incorrect? The class width is the difference between the two consecutive lower class limits. All right, good deal. So the class width is not 1. The class width, as I taught you previously, is the difference between the lower bounds of each class. So it's kind of embarrassing that happened, but actually from a teaching perspective, I'm actually glad it did happen because it shows you what happens when you get it wrong. You have to rethink. And even when you do this as much as me, sometimes it's possible to make goofy um, uh, mistakes. Now, down at the bottom, it's probably a good time to bring this in. You have a help me solve this. Let me show you what happens there. Help me solve this will run through and prompt you with questions about how to solve this problem, right? Uh, view an example is another thing that you can, an option in my stat lab that you can use if you're having problems. And that it will run through the instruction and show you how they get the answers from a related problem. So, and then there's options for get more help, ask my instructor. If this doesn't work and you just need to reach out to me, you can send me an email via this link. Looks like we're going to have to start over, right? Daggone it. All right, so let's well, that was annoying. All right, identify the upper class limits. So that's going to be 24, 29. I got on autopilot there. 24, 29, 34, 39. Yeah, tedious work. This kind of stuff drives me insane, I'll just tell you. Identify the class width. Let's do it correctly this time. So we go from 20 to 25 is 5 units, so obviously 5. Identify the class midpoints. Well, the midpoint would be the center of the interval. So the center of the interval, the easiest way to find this is just to add 20 plus 24 and divide by 2, which would be 22. Same thing here would be 27. All of these are going to increase by 5, the class width. They're not going to increase by 5 on every single problem. They're going to increase by 5 on this problem because the class width is 5. Identify the class boundaries. This is interesting. Interesting question. To be in this first, well, let's talk about this one. Let's talk about the 35 to 39. What values would be in there? Well, anything from 34.5, the upper bound of the previous bin and the lower bound of the next bend. Where is the decision point there? Well, it's midway. It's between 34 and 35, which would be 34.5. So applying that logic, we would have 0.5 below the 20, which would be 19.5. And then separating this bin, the first bin and the second bin, would be 24.5. And then separating 29.5 and 30 would be 29.5, of course. And then 34.5, 39.5, 44.5. I'm always worried about a typo here. And then the upper would be, of course, 54.5. Identify the number of individuals included in the summary. That's just going to be the sum of these. So we have 65, 77, 87, 88, 89. All right, next question. Okay, I guess that's it. I guess that's the sixth question. All right, I hope this helped. Again, just an intro to one of our simpler concepts, frequency distribution. Take care.